Good morning, students. Welcome back to physics revision class. So, in the last class, we discussed on the 3 marks question, that is part C, right? So, up to 3 questions we have completed in our last class, right? That is for 3 marks questions, right? So, today, start with the question, that is fourth question, right? Derive the expression for potential energy. So, in that, two sub questions are there. So, first one is a system of two charges in the absence of external electric field, right? So, question number 4, in the first one, potential energy of a system of charges with external electric field, right? So that is potential energy is the electrostatic potential energy. So what is potential energy? So potential energy is the total amount of work done in bringing the charge, that is bringing the unit charge from infinity to any point. So in an against the electric field without any acceleration. So that is the definition of the potential energy. That means we are bringing one unit charge from infinite place to any point. So opposite to that of the, that is against to that of the electric field, right? So against to that of the electric field, we are bringing one unit positive charge. So without any acceleration, that means external force we are applying onto the charge is zero. That means acceleration is zero, means applied force is zero, right? So against the electric field, so it experiences the force, right? So opposite to the direction of the displacement. So hence the work is done, right? So that work done stores as the potential energy, right? So in this question they are asking to derive the relation for the potential energy of a system of two charges. That means we need to find the potential energy of the two charges without any external electric field, right? So in this derivation, first bringing the unit charge from infinite to any point. So that point we taken as A, right? So at the point A, we are bringing one unit charge. So that charge we taken as Q1, right? So around this region there is no any external field. So hence work done in bringing the charge Q1 from infinite to point A is 0. Why? Because there is no any external field. So external field illa. So external field illa ಅಂದ್ರೆ ಯಾವುದೇ ತರಹದ force ಇಲ್ಲ. So force ಇಲ್ಲ ಅಂದ್ರೆ ಅಲ್ಲಿ ನಮಗೆ ಏನಾಗಲ್ಲ, work done ಆಗೋದಿಲ್ಲ, right? So force work done ಗೆ relation ಇದೆ force into displacement. So actually displace ಆಗ್ತಿದೆ from infinite to the point A, but there is no force, right? So hence work done in bringing the charge Q1 from infinite to point A is 0, right? That is why, because there is no any external electric field, right? So in the question also they mentioned without any external field, right? So ಯಾವುದೇ ತರದ external field ಇಲ್ಲ. So that's why work done in bringing the charge Q1 from infinite to point A is 0. So first we need to write the statement, right? Work done in bringing the charge Q1 from infinite to point A is 0, right? So why 0? That is because there is no any external electric field. So external electric field illa andre alli namage force irodilla. So force illa andre alli namage work done agalla. So work done ge relation enide force into displacement. So the charge is displacing from infinite. So infinite ಇಂದ ಈ ಚಾರ್ಜ್ ತಗೊಂಡು ಬರ್ತಾ ಇದೀವಿ. So ಯಾವುದೇ ತರದ external field ಇಲ್ಲ. So hence there is no work done in bringing the charge Q1, right? So next, consider a point B at a distance R from A, right? So we are considering one point B at a distance R from the point A or from Q1, right? So we are considering one point B from the charge Q1. So first we need to find the potential at the point B due to charge Q1, right? ಸೊ ಇಲ್ಲಿ ನಮಗೆ ಚಾರ್ಜ್ ಇದೆ ಅಂದ್ರೆ, ಸೊ ಚಾರ್ಜ್ ಇದೆ ಅಂದ್ರೆ ಎಲೆಕ್ಟ್ರಿಕ್ ಫೀಲ್ಡ್ ಇರುತ್ತೆ. ಸೊ ಎಲೆಕ್ಟ್ರಿಕ್ ಫೀಲ್ಡ್ ಇದೆ ಅಂದ್ರೆ ಅಲ್ಲಿ ನಮಗೆ ಫೋರ್ಸ್ ಇರುತ್ತೆ, ರೈಟ್? ಸೊ ಎಲೆಕ್ಟ್ರಿಕ್ force, right? So due to that force we need to find the potential at B, right? So the potential at a point B due to charge Q1, right? So we are finding the potential at point B. So ಇಲ್ಲಿ potential ನ find out ಮಾಡ್ತಾ ಇದೀವಿ. That is because of due to the charge Q. So ಇಲ್ಲಿ Q1 ಇದೆ ಅಂತ ಹೇಳ್ಬಿಟ್ರೆ Q1 ಇಂದ ನಮಗೆ ಏನು ಬರ್ತಾ ಇದೆ? Electric field ಇದೆ. So yeah, electric field means the electric field lines which are coming out from the charge. So ಯಾವುದಾದ್ರೂ ಒಂದು ಚಾರ್ಜ್ ಇದೆ ಅಂದ್ರೆ surrounding space ಅಲ್ಲಿ ನಮಗೆ ಏನಿರುತ್ತೆ? Electric field ಇರುತ್ತೆ, right? So due to that electric field we are going to find the potential at point B, right? So the potential at point B, that is due to charge Q1. So the relation is potential V1, that is equals to 1 divided by 4 pi epsilon naught Q1 divided by R. So E point ಅಲ್ಲಿ ನಮಗೆ potential ಎಷ್ಟಿದೆ? That we get the relation V1 is equals to 1 by 4 pi epsilon naught Q1 by R, right? So ನಮಗೆ one charge ಆಯ್ತು. So next ಏನು ಹೇಳ್ತಾ ಇದ್ದಾರೆ? System having two charges. So one charge ಆಗಿದೆ. So now we are bringing one more charge from infinity, right? So we are bringing one more charge from infinity to the point B. So that charge we take as Q2, right? So now here we are bringing the charge from infinity to the point B against the electric field, right? So ಇದು ನಮಗೆ ಯೂನಿಟ್ ಚಾರ್ಜ್ ಅಂತ ತಗೊಂಡ್ರೆ it is always positive. So direction of the electric field line in the radial ಎಲ್ಲ ಡೈರೆಕ್ಷನ್ ಅಲ್ಲೂ ಇರುತ್ತೆ, right? So we are bringing the charge opposite to that of the electric field, right? So that means displacement is opposite to that of the electric field. So electric field ಇದೆ ಅಂದ್ರೆ ಇಲ್ಲಿ ನಮಗೆ ಫೋರ್ಸ್ ಇರುತ್ತೆ. So force direction, electric field direction both are same, right? So force ಯಾವ ಕಡೆಗೆ ಆಕ್ಟ್ ಆಗ್ತಾ ಇರುತ್ತೆ ಅಂದ್ರೆ in the direction of electric field. So electric field ಯಾವ ಡೈರೆಕ್ಷನ್ ಅಲ್ಲಿ ಇರುತ್ತೋ ಆ ಡೈರೆಕ್ಷನ್ ಅಲ್ಲಿ ಫೋರ್ಸ್ ಆಕ್ಟ್ ಆಗ್ತಾ ಇದೆ, right? So force is also acting in this direction. So ಇದು ಎಕ್ಸಾಮ್ ಅಲ್ಲಿ ನಿಮಗೆ ನೆಸೆಸರಿ ಇಲ್ಲ, ಬಟ್ ಇಲ್ಲಿ ಅಂಡರ್ಸ್ಟ್ಯಾಂಡಿಂಗ್ ಪರ್ಪಸ್ ಗೋಸ್ಕರ ಹೇಳ್ತಾ ಇರೋದು, right? So force and electric field both are vectors, both are acting in the same direction. So I am bringing the charge from infinite. So ಇದು infinite ಅನ್ಕೊಂಡ್ರೆ from here I am bringing the charge Q2, right? Like this. So displacement is opposite to that of the force. That is what I am saying is we are bringing the charge Q2 from infinity against to the point B against the electric field. So electric field direction ಈ ಕಡೆ ಇದೆ ಅಂದ್ರೆ we are bringing the charge opposite to that of the electric field. That means here we have the force and also we have the displacement, right? So infinity ಇಂದ ನಾವು ತಗೊಂಡು ಬರ್ತಾ ಇದೀವಿ ಅಂದ್ರೆ displacement ಇದೆ, ಜೊತೆಗೆ force ಕೂಡ ಇದೆ, but both are opposite direction. That means negative work ಅಂತ ನಾವು ಕರೀತೀವಿ, right? So ಎರಡು opposite ಇತ್ತು ಅಂದ್ರೆ negative work, ಎರಡು same direction ಇತ್ತು ಅಂದ್ರೆ positive work, right? So here hence the work is done in bringing the charge Q2 from infinity to point B, right? So work done in bringing the charge Q2 against the field due to Q1, right? So ಇಲ್ಲಿ ಫೀಲ್ಡ್ ಯಾವುದು ಪ್ರೊಡ್ಯೂಸ್ ಮಾಡ್ತಾ ಇದೆ? ಚಾರ್ಜ್ Q1 ಪ್ರೊಡ್ಯೂಸ್ ಮಾಡ್ತಾ ಇದೆ. So against the field we are bringing the charge Q2. So hence work is done. So ಅಲ್ಲಿ ಏನಾಗ್ತಾ ಇದೆ? ನಮಗೆ ವರ್ಕ್ ಆಗ್ತಾ ಇದೆ. So that work we are going to find out, right? So work done W, right? So work done W is equals to potential at the point B into charge Q2, right? So work done W is equals to V1 into Q2, right? So infinity in the point B ಮಾಡ್ತಾ ಇದೀವಿ ಯಾವ ಚಾರ್ಜ್ ನ? Q2 ಅನ್ನೋ ಚಾರ್ಜ್ ನ. So here we have the potential. So potential ಇದೆ, the relation between the work done and potential is W is equals to V into Q or W by Q. That term, that ratio we call as the potential. So here V1 is the potential which is produced by the charge Q1, right? So we have the value of V1, that is 1 divided by 4 pi epsilon naught Q1 Q2 divided by R, right? So this work done is stored as potential energy, and that is W is equals to U, and that is equals to 1 by 4 pi epsilon naught Q1 Q2 divided by R. So this is the final expression, right? So 3 marks here, simple and important relation, right? So we need to understand. So ಇಲ್ಲಿ ನಮಗೆ lengthy steps ಇಲ್ಲ ಅಥವಾ lengthy explanation ಏನಿಲ್ಲ. Just we have two statements and two relations, right? So simple ಆಗಿ ನೆನಪಿಟ್ಕೋಬೇಕು ಅಂದ್ರೆ first we are bringing the charge. So ಯಾವುದೋ ಒಂದು ಚಾರ್ಜ್ ನ ತಗೊಂಡ್ ಬರ್ತಾ ಇದೀವಿ. So ಇಲ್ಲಿ ಯಾವುದೇ ತರದ್ದು external electric field ಇಲ್ಲ ಅಥವಾ ಯಾವುದೇ ಚಾರ್ಜ್ ಇಂದನೂ ಫೀಲ್ಡ್ ಪ್ರೊಡ್ಯೂಸ್ ಆಗ್ತಾ ಇಲ್ಲ. So ಅದಕ್ಕೋಸ್ಕರ ಅಲ್ಲಿ ಏನಾಗ್ತಾ ಇಲ್ಲ ನಮಗೆ ವರ್ಕ್ ಡನ್ ಆಗ್ತಾ ಇಲ್ಲ. So ಅದು first statement, right? So next we are finding the potential at any point at a distance r from a. So next ಏನು find out ಮಾಡ್ತಾ ಇದೀವಿ, potential find out ಮಾಡ್ಕೊಂತಾ ಇದೀವಿ at any distance r in any space. So ಇದನ್ನ ಇಲ್ಲೇ ಬರಿಬೇಕು ಅಂತ ಏನಿಲ್ಲ, ಇಲ್ಲಿ ಬೇಕಾದರೂ ಅದನ್ನ ನೋಟ್ ಮಾಡ್ಕೋಬಹುದು, right? So we are finding the potential at a point b. So from the relation, so potential topic ಅಲ್ಲಿ ನಾವು ಡಿಸ್ಕಸ್ ಮಾಡಿರೋದ್ರಿಂದ we have the relation v1 is equals to, so potential due to q1 ಇರೋದ್ರಿಂದ v1, right? So V1 is equals to 1 by 4 pi epsilon naught Q1 by R, right? So next here we are bringing the another charge Q2 to the point B. So second charge ನಾವು ತಗೊಂಡ್ ಬರ್ತಾ ಇದೀವಿ, same, that is from infinite. So infinite ಅಂದ್ರೆ ಅದು ಎಲ್ಲಿಂದನಾದ್ರೂ ತಗೊಂಡ್ ಬರಬಹುದು. So it is path independent. ನಾವು ಯಾವ path ಅಲ್ಲಿ ಬೇಕಾದ್ರೂ ಅದನ್ನ ತಗೊಂಡ್ ಬರಬಹುದು. But here in this case, so Q2 ಅಲ್ಲಿ ವರ್ಕ್ ಡನ್ ಆಗ್ತಾ ಇದೆ. ಏನಕ್ಕೆ ಆಗ್ತಾ ಇದೆ? That is because of due to the electric field which is produced by Q1. So Q1 ಏನು ಪ್ರೊಡ್ಯೂಸ್ ಮಾಡ್ತಾ ಇದೆ? ಎಲೆಕ್ಟ್ರಿಕ್ ಫೀಲ್ಡ್ ಪ್ರೊಡ್ಯೂಸ್ ಮಾಡ್ತಿದೆ. So due to this electric field it has the force. So force ಇದೆ, ಜೊತೆಗೆ ಡಿಸ್ಪ್ಲೇಸ್ಮೆಂಟ್ ಇದೆ, ಎರಡು ಇದೆ ಅಂದ್ರೆ ಅಲ್ಲಿ ಏನಾಗ್ತಾ ಇದೆ ನಮಗೆ ವರ್ಕ್ ಡನ್ ಆಗ್ತಾ ಇದೆ. So that we are going to find the work done in bringing the charge Q2 against the field which is produced by Q1, right? So we have the relation to find the work done. W is equals to V1 into Q2, right? So V1 already we find the value, right? So substitute and simplify. So this gives the relation for the potential energy, right? So general ಆಗಿ potential energy ಅಂತ ಕೇಳಿದ್ರು ಕೂಡ ಇದನ್ನ ಡಿಫೈನ್ ಮಾಡಬೇಕು, right? So system of two charges. So in case of electric field ಅಂತ ಹೇಳಿದ್ರೆ one more term ಅದಕ್ಕೆ ಆಡ್ ಆಗ್ತಾ ಹೋಗುತ್ತೆ, right? So next, in this second one, a dipole which is placed in a uniform electric field, right? So here two charges. So here unit charges, these two charges are always positive. So ಎರಡು unit charge ಕೂಡ ಏನಂತ ಕನ್ಸಿಡರ್, unit charge ಅಂದ್ರೆ those are the positive charges, right? So ಅದin reference ಗೆ ಅದು positive charge ಅಲ್ಲೇ ಇರುತ್ತೆ, right? So second we are going to find the potential energy which is due to a dipole. Dipole means two charges, that is equal charges but opposite in signs. So ಒಂದು plus q1 ಇತ್ತು ಅಂದ್ರೆ ಇನ್ನೊಂದು minus q ಇರುತ್ತೆ, right? So dipole ಅಂತ ನಾವು ಕೇಳಬಹುದು ಅಥವಾ two equal and opposite charges ಅಂತ ನಾವು ಕೇಳಬಹುದು. Right. So fourth one, second one, potential energy of a dipole, right? So what is dipole? Dipole is a, that is dipole is defined as two equal and opposite charges separated by a small distance, right? So consider a dipole. So minus q plus q separated by a small distance, so that distance we taken as 2a, right? So 2a is the distance between the separation of the two similar, that is equal and opposite charges. So ಎರಡರದ್ದು magnitude ಏನಿರುತ್ತೆ ನಮಗೆ ಸೇಮ್ ಇರುತ್ತೆ, but sign ಏನಿರುತ್ತೆ opposite ಇರುತ್ತೆ, right? So consider a dipole, right, having a dipole moment p. right? So dipole moment is always from negative charge to positive charge, right? So dipole moment is nothing but it is the product of magnitude of charge into the distance of separation. So P is equals to Q into 2A, that we call as the dipole moment, right? So dipole electrolyte considered a dipole having a dipole moment P, which is placed in an uniform electric field, right? So this dipole which is placed in a uniform electric field. So uniform electric field we need to draw the electric field lines. So E is the electric field, right? So dipole question of a dipole in a uniform electric field, right? So first we need to write the explanation. So for that, consider a dipole having a dipole moment P, which is placed in a uniform electric field E, right? So due to the electric field, the plus Q charge experiences the force, that is F, right? So this force is in the direction of the electric field. So force is a vector, electric field is a vector, right? So both having a magnitude and direction. So here the charge is plus Q, hence it experiences a force. So that force is in the direction of the electric field. So positive charge ಆಗಿರೋದ್ರಿಂದ force experience ಆಗ್ತಾ ಇದೆ ಆ charge ಗೆ due to the electric field. So force direction ಯಾವ ಕಡೆ ಇರುತ್ತೆ ಅಂದ್ರೆ that direction is in the direction of the electric field. So electric field ಯಾವ direction ಅಲ್ಲಿ ಇರುತ್ತೋ ಅದೇ direction ಅಲ್ಲಿ force direction ಕೂಡ ಇರುತ್ತೆ, right? So same case here also we having the charge minus Q. So this charge is also experiences the force. So force experience ಆಗ್ತಾ ಇದೆ, that is due to the electric field E, right? So but here the charge is negative, hence it experiences a force. That direction is opposite to that of the electric field. So electric field direction ಗೆ opposite ಆಗಿ force experience ಆಗ್ತಾ ಇದೆ, right? So plus Q charge experiences a force in the direction of the electric field, minus Q charge experiences a force opposite direction of the electric field. So electric field right side ಅಲ್ಲಿ ಇತ್ತು ಅಂದ್ರೆ force ನಮಗೆ left side ಅಲ್ಲಿ ಇರುತ್ತೆ, right? So dipole ಅಲ್ಲಿ charge having the same magnitude. So for example Q ಗೆ 1 coulomb ಇತ್ತು ಅಂದ್ರೆ ಇಲ್ಲಿ Q ಕೂಡ 1 coulomb ಇರುತ್ತೆ. So uniform electric field ಇರೋದ್ರಿಂದ ಇಲ್ಲಿ ಪ್ರೊಡ್ಯೂಸ್ ಆಗ್ತಿರೋ ಫೋರ್ಸ್ ಏನಿರುತ್ತೆ ಅದಕ್ಕೆ ಈಕ್ವಲ್ ಆಗಿ ಇಲ್ಲಿ ಫೋರ್ಸ್ ಪ್ರೊಡ್ಯೂಸ್ ಆಗ್ತಾ ಇರುತ್ತೆ, right? So the magnitude of the force are same because the charge are same and the uniform electric field. So hence force experienced by plus Q is equals to the force experienced by minus Q. Hence the net force acting on the dipole is 0, right? So why 0 means F is equals to plus Q into E. So here F is equals to minus Q into E, right? So magnitude na consider madidra plus QE minus QE get cancelled, so net force is equals to 0, right? So we need to mention that statement. So net force acting on the dipole, right? So F net, that is equals to QE minus QE, that is equals to 0, right? So here F, that is equal to Q into E. So here F is equals to Q into E, that is minus Q into E, right? That is because of minus charge, right? So minus indicates what? The direction of the force is opposite to that of the electric field, right? So this is the condition, right? So dipole ಅಲ್ಲಿ net force 0 ಆಗ್ತಾ ಇತ್ತು ಅಂದ್ರೆ then there exists a torque, right? So torque is produced. So only when force acting on the dipole is 0. So ಯಾವಾಗಲೂ net force 0 ಆಗ್ತಾ ಇದೆ ಅಂದ್ರೆ ಅಲ್ಲಿ ಏನು ಜನರೇಟ್ ಆಗ್ತಾ ಇದೆ ನಮಗೆ torque ಜನರೇಟ್ ಆಗ್ತದೆ, right? So torque, so we have the relation. So torque, that is tau, that is equals to PE sin theta into n cap, right? So ಇದನ್ನು ಕೂಡ ನಾವು ಡಿರೈವ್ ಮಾಡ್ಕೊಂಡಿದ್ವಿ torque in a dipole, right? So torque tau is equals to PE sin theta. So where P is the dipole momentum, E is the uniform electric field, right? So here if we consider O as the center of the dipole, right? So here we are getting the angle theta, right? So that is the angle between P and E. So sin theta in the one. So sin theta is the angle between E vector and P vector. That is dipole moment vector to the electric field vector. Right. So torque is a cross product. So maths ಅಲ್ಲಿ ಕೂಡ ಸ್ಟಡಿ ಮಾಡಿದ್ದೀರಾ dot product ಮತ್ತೆ cross product. So ಇದನ್ನ ನಾವೇನು ಬರೆಯಬಹುದು P cross E. So multiplication of two vectors, again we are getting a vector, right? So tau is equals to P sin theta and n cap is the direction, right? So we need to find the potential energy. So before going to find the potential, first we need to find the work done. So work done in rotating dipole, right? So work done. So initially we consider the small work done dW, right? So dW, that is equals to tau into d theta. Why d theta means, so small rotation of the dipole, so rotate ಆಗ್ತಾ ಇದೆ ಅಂದ್ರೆ small work done ಆಗ್ತದೆ. So total rotation ಆಯ್ತು ಅಂದ್ರೆ ನಮಗೆ total work done ಸಿಗುತ್ತೆ, right? So we know the relation for tau, that is PE sin theta into d theta, right? So now we are going to find the total work done. Total work done W, that is equals to integration or summation. So ella kada integration use ಮಾಡ್ತಿರೋದ್ರಿಂದ integration from theta 1 to theta 2. So rotation of the angle from theta 1 to theta 2 into dW, right? So dW ಗೆ ನಮಗೆ relation ಇದೆ. So substitute ಮಾಡಿದ್ರೆ W is equals to theta 1 to theta 2 PE sin theta into d theta, right? So dipole moment constant is there, electric field kuda constant is there. So these two terms are constant, so we can take common, that is outside PE theta 1 theta 2 sin theta d theta. So integration with the differentiation both are opposite, right? So differentiation of sin theta we are getting cos theta. So if we integrate the cos theta, then we are getting the sin theta, right? So same way here is the integration. So differentiation of sin theta is what? Cos theta, right? So integration of sin theta is minus cos theta, right? So work done W is equals to minus PE cos theta. So substituting the limits theta 1 to theta 2. So ಇದು ನಿಮಗೆ ಇಂಟಿಗ್ರೇಷನ್ ಅಲ್ಲಿ ಬರುತ್ತೆ, right? So PE, so substituting the limit, upper limit theta 2 and lower limit theta 1 cos theta 1. So right, considering theta 2 is equals to theta 1 is equals to pi by 2, right? So always therefore we are taken in the vertical form. So e ತರ ತಗೊಂಡ್ರಿಂದ plus q minus q. So angle between dipole moment p ಮತ್ತೆ electric field E ಎಷ್ಟಿರುತ್ತೆ ಅಂದ್ರೆ pi by 2, 90 degree. So ಈ ರಿಲೇಷನ್ ನ ಕನ್ಸಿಡರ್ ಮಾಡ್ಕೊಂತಾ ಇದೀವಿ, right? So substituting here W is equal to minus PE cos theta minus cos theta 1 is cos pi by 2. So cos pi by 2 is 0, right? So this work done is stored as the potential energy, right? So that is U is equals to minus PE cos theta. So this one is the final expression and it is very important, right? So important relation. So simple is that just first we need to consider one dipole having the dipole moment P, which is placed in an uniform electric field. So instead is with explanation. So next explanation is the net force acting on the dipole is 0. So ಇದನ್ನ ಡೈರೆಕ್ಟ್ ಆಗಿ F net is equals to 0 ಅಂತ ನಾವು ಬರೆಯಬಹುದು. So ಇದು ಬರೆದ್ರೆ ಕೆಳಗಡೆ ಏನೇ ಬರೋದ್ರೂ ಅದಕ್ಕೆ ಮೀನಿಂಗ್ ಇರುತ್ತೆ. So ಇದನ್ನ ನೀವು ಬಿಟ್ಟು ಡೈರೆಕ್ಟ್ ಆಗಿ ಈ ಸ್ಟೆಪ್ಸ್ ಬರೆದ್ರೆ it has no meaningless, right? So when net force acting on the dipole is 0, then only we are getting the torque. Net force 0 ಆದ್ರೆ ಮಾತ್ರ ನಮಗೆ torque ಪ್ರೊಡ್ಯೂಸ್ ಆಗುತ್ತೆ. So net force 0 ಆಗಿಲ್ಲ ಅಂದ್ರೆ ನಮಗೆ torque ಪ್ರೊಡ್ಯೂಸ್ ಆಗೋದಿಲ್ಲ, right? So net force 0 ಆಗುತ್ತೆ. So hence torque is generated. So torque from the relation we know PE sin theta into n cap, right? So torque is nothing but the rotating force. So torque na navenanta kariತೀವಿ rotating force anta kariತೀವಿ. So due to this force in an electric field, so it is rotating. So ಈ ಡೈಪೋಲ್ ಏನಾಗ್ತಾ ಹೋಗುತ್ತೆ, rotate ಆಗ್ತಾ ಹೋಗುತ್ತೆ. So hence rotate ಆಗ್ತಾ ಇದೆ ಅಂದ್ರೆ due to that force work done displace ಆಗ್ತಾ ಇದೆ by an angle theta. So hence work is done. So that is we find the relation work done is equals to tau into d theta, right? So tau value ಗೊತ್ತಿದೆ, that is the torque. So substitute ಮಾಡಿ. So this gives what the small work done. So to find the total work done we need to integrate. So integration ಅಲ್ಲಿ ನಿಮಗೆ ಡೈರೆಕ್ಟ್ ಆಗಿ ಇದನ್ನು ಬರೆದ್ಬಿಟ್ಟು so directly you can write this step, right? So you can jump the steps. So ಈ steps ನ ನೀವು jump ಮಾಡಿ ಡೈರೆಕ್ಟ್ ಆಗಿ ಈ ಕಂಡೀಷನ್ ನ ಬರಿಬಹುದು. So directly we can write the integration theta 1 to theta 2 p sin theta. We can write w is equals to minus p cos theta 2 minus cos theta 1, right? So next, considering the general case, that is theta 1 is pi by 2, right? So angle starts from pi by 2. So e angle in the theta 1 pi by 2, then theta 2 we can take that as theta. So general ಆಗಿ ತಗೊಂಡ್ರೆ ಅದನ್ನ theta ಅಂತ ತಗೊಂತೀವಿ. So we get u is equals to minus pe cos theta, right? So next, fifth one, derive the expression for capacitance of a parallel plate capacitor. So next question is fifth one, expression for parallel plate capacitor, right? So parallel plate capacitor is different from two capacitors which are connected in parallel. So eradukku confuse agabadi. So this one is the relation which we are going to find, that is C is equals to epsilon naught A divided by B, right? So our question kuda ide, seventh question ide, obtain the expression for the effective capacitance when two capacitors are connected in parallel. So that question is different from this question, right? So every question similar anta ansute. So but you need to know parallel plate capacitor means the capacitor which consists of two conductors which are placed in parallel, right? So ಎರಡು conductors na parallel ಆಗಿ small distance d ಅಲ್ಲಿ place ಮಾಡಿದ್ರೆ ಅಲ್ಲಿ ನಮಗೆ ಸಿಗೋದನ್ನ capacitance na find out ಮಾಡಿದ್ರೆ ಅದನ್ನ ಏನಂತ ಕರಿತೀವಿ, expression for the parallel plate capacitor. So confuse ಆಗಬೇಡಿ ಆ ಕ್ವೆಶ್ಚನ್ ಗೆ ಮತ್ತೆ ಇದಕ್ಕೆ, right? So ತುಂಬಾ confuse ಆಗಿ ಅದೇ ರಿಲೇಶನ್ ನ ಡಿರೈವ್ ಮಾಡ್ತಾರೆ, right? So consider two parallel plates having area A, right? So A is the area of the each plate. So that means these are the two conductors separated by a small distance d, right? So explanation. So elladukku kuda explanation important. So blind of only mathematical steps barudre adukke meaning iradilla, then so marks cut aga chances tumba irutte, right? Because irode 3 marks, adrallu nimge only steps ಗೆ 1 marks ಕೊಡ್ತಾರೆ ಅಷ್ಟೇ, right? So first consider two parallel plate conductors which are placed or separated by a small distance d, when A is the area of the each plate, right? So now these parallel plate conductors are connected to the external source, that is external potential, right? So ಈ ಎರಡು ಕಂಡಕ್ಟರ್ಸ್ ನ ಎಲ್ಲಿ ಕನೆಕ್ಟ್ ಮಾಡ್ತಾ ಇದೀವಿ, external potential, that is V, right? So ಇಲ್ಲಿ ಪಾಸಿಟಿವ್ ಸೈನ್ ಇರೋದ್ರಿಂದ ಪಾಸಿಟಿವ್ ಚಾರ್ಜಸ್ ಫ್ಲೋ ಆಗುತ್ತೆ. So hence the first conductor gets positively charged, right? So ಎಷ್ಟು ಚಾರ್ಜಸ್ ಸ್ಟೋರ್ ಆಗುತ್ತೋ, so the same charges, negative charges will be stored on the second conductor, right? So where sigma is the linear charge density. So linear, that is uniform distribution. So charges ಏನಾಗುತ್ತೆ uniform ಆಗಿ plate ಮೇಲೆ distribute ಆಗುತ್ತೆ. So we are considering only one plate, right? So ಈ plate ಆದ್ರೂ consider ಮಾಡಬಹುದು ಅಥವಾ ಈ plate ಆದ್ರೂ consider ಮಾಡಬಹುದು, right? So where sigma is the linear charge density, right? So sigma is the linear charge density, and we have the relation that is sigma is equals to q divided by a, right? Surface charge density area, right? So sigma is the surface charge density. So sigma is equals to q divided by a, right? So this is the relation for sigma and charge q, right? So when the external potential is connected to the conductors, then the electric field is generated from positive charge to the negative charge, right? So ಇಲ್ಲಿ ಏನು ಪ್ರೊಡ್ಯೂಸ್ ಆಗ್ತದೆ ನಮಗೆ electric field. So electric field lines is always from positive charge to the negative charge. So this electric field is produced due to the potential which we are connected externally to the conductors. So ಈ ಎರಡು ಕಂಡಕ್ಟರ್ಸ್ ಗೆ ನಾವು outside source ಗೆ ಕನೆಕ್ಟ್ ಮಾಡಿದೀವಿ. So first plate gets positive charge and the second plate gets negative charge. So ಇಲ್ಲಿ ನಾವು ಸೈನ್ ನ ರಿವರ್ಸ್ ಮಾಡ್ಕೊಂಡ್ರೆ ಈ ಕಡೆ ಪ್ಲಸ್ ನ ಕನೆಕ್ಟ್ ಮಾಡಿದ್ರೆ ಇಲ್ಲಿ ಪ್ಲಸ್ ಸ್ಟೋರ್ ಆಗುತ್ತೆ, ಸೊ ಇಲ್ಲಿ ಮೈನಸ್ ಸ್ಟೋರ್ ಆಗುತ್ತೆ. ಸೊ ನೀವು ಡಯಾಗ್ರಾಮ್ ಬರೀಬೇಕಾದ್ರೆ ಕೇರ್ಫುಲ್ ಆಗಿ ಬರೀಬೇಕು. ಸೊ ಪೊಟೆನ್ಷಿಯಲ್ ಪಾಸಿಟಿವ್ ಇರೋ ಕಡೆ ಪಾಸಿಟಿವ್ ಚಾರ್ಜಸ್ ಸ್ಟೋರ್ ಆಗುತ್ತೆ, ಸೊ ನೆಗೆಟಿವ್ ಇರೋ ಕಡೆಗೆ ನೆಗೆಟಿವ್ ಚಾರ್ಜಸ್ ಸ್ಟೋರ್ ಆಗುತ್ತೆ. ದೆನ್ ಎಲೆಕ್ಟ್ರಿಕ್ ಫೀಲ್ಡ್ is always from positive charge to negative charge. So this electric field is generated, that is due to the potential V, right? So electric field produce ಆಗ್ತಾ ಇದೆ ಯಾವುದರಿಂದ ನಮಗೆ external potential apply ಮಾಡಿರೋದ್ರಿಂದ, right? So we know the relation for the electric field and to that of the potential, right? So now 3 marks relation ಅಲ್ಲಿ derive ಮಾಡಿದ್ವಿ, right? So that is E is equals to dV by dL, right? So that is the relation between the potential and electric field. So this we can write E is equals to V by L. So ಇದು ಸ್ಮಾಲ್ ಚೇಂಜ್ ಇರೋದ್ರಿಂದ dV ಅಂತ ತಗೊಂಡಿದ್ದೀವಿ. So in general if we write the relation for electric field and potential, so E is equals to V by L. So ಇದು ನಮಗೆ ಥರ್ಡ್ ಡಿರೈವೇಶನ್ ಅನ್ಸುತ್ತೆ. So ಲಾಸ್ಟ್ ಕ್ಲಾಸ್ ಅಲ್ಲಿ ಇದನ್ನ ಡಿರೈವ್ ಮಾಡ್ಕೊಂಡಿದ್ವಿ, right? So here also the electric field is produced. So electric field produce ಆಗ್ತಾ ಇದೆ within the distance d. So ಈ d distance ಅಲ್ಲಿ electric field produce ಆಗ್ತಾ ಇದೆ, that is because of the potential V. So now we relate the relation for electric field and to that of the potential, then E is equals to V divided by D, right? So electric field E is equals to V divided by D. So we need the potential, right? So potential V is equals to E into D, right? So calling this as the first relation, right? So from the previous chapter, that is first chapter, infinite or a finite conductor which having the surface charge density, then we have the relation for the electric field, right? So electric field in an uniform plate, right? So that is again the applications of the Gauss law. So Gauss law application in the we can find the electric field in an uniform plate. So uniform surface charge density, right? So uniform surface charge density. So again we have the relation electric field due to the plate 1, due to the first plate or first conductor. So ಇದನ್ನ 1 ಅಥವಾ ಇದನ್ನ 2 ಅಂತ ಕನ್ಸಿಡರ್ ಮಾಡಿದ್ರೆ, so due to the first plate, so electric field E is equals to, right? So that relation is sigma divided by epsilon naught. So ಇದನ್ನ ನಾವು ಫಸ್ಟ್ ಚಾಪ್ಟರ್ ಅಲ್ಲಿ ಅಪ್ಲಿಕೇಶನ್ಸ್ ಆಫ್ ಗಾಸ್ ಲಾ ದಲ್ಲಿ ಡಿರೈವ್ ಮಾಡ್ಕೊಂಡಿದ್ದೀವಿ, right? So electric field is equals to sigma by epsilon. Now substitute this value to the first relation, so we get the potential V is equals to sigma d divided by epsilon. Or so better here only we can substitute the value of sigma to the electric field E, right? So that is equals to Q divided by A into epsilon naught, right? Otherwise, all this one is first relation, this one is second. So in the bracket, that is from equation 1, right? So again, this has third relation. So substitute equation 3 in 2. So equation 3, E again, we need to substitute this value, then V is equals to QD divided by A epsilon naught, right? So from the definition of capacitance, so from the definition of the capacitance, so C is equals to Q divided by B, right? So this is from the definition, it is the ratio of the charge to the potential, right? So C is equals to Q by V, so C is the capacitance we are finding in between the two parallel plate conductors, right? So from third equation, so or fourth equation, from the fourth equation we have the value of V, that is QD divided by A epsilon naught, right? So in the numerator Q, in the denominator Q get cancelled, so hence capacitance of a parallel plate capacitor C is equals to epsilon naught A divided by D, right? So ಇದು ಕೂಡ ತುಂಬಾ ಇಂಪಾರ್ಟೆಂಟ್ 3 marks ಅಲ್ಲಿ. So ತುಂಬಾ ಸಲ ಕೇಳಿರೋ ಕ್ವೆಶ್ಚನ್ ಕೂಡ ಇದೆ, right? So simple relation in both the cases. First we need to find the electric field. So electric field na find out ಮಾಡ್ಕೊಂತಾ ಇದೀವಿ. One is, that is relation between the electric field and to that of the potential, and again the electric field we are going to find due to the single plate. So one plate in the now electric field na find out ಮಾಡ್ಕೊಂತಾ ಇದೀವಿ, that is E is equals to sigma by epsilon naught, right? So textbook ಅಲ್ಲಿ ಕೆಲವು ಕಡೆ ಅದನ್ನ ಮತ್ತೆ ಲೆಂಥಿ ಆಗುತ್ತೆ. ಸೊ 2 ಸರ್ಫೇಸ್ ಏರಿಯಾ ಇರೋದ್ರಿಂದ ಅದನ್ನ ಸಿಗ್ಮಾ ಬೈ ಎಪ್ಸಿಲಾನ್ ನಾಟ್ ಮತ್ತೆ ಸಿಗ್ಮಾ ಬೈ ಎಪ್ಸಿಲಾನ್ ನಾಟ್ ತಗೊಂಡು, ದಟ್ ಇಸ್ ಸಿಗ್ಮಾ ಬೈ 2 ಎಪ್ಸಿಲಾನ್ ನಾಟ್ ಪ್ಲಸ್ ಸಿಗ್ಮಾ ಬೈ 2 ಎಪ್ಸಿಲಾನ್ ನಾಟ್. ಸೊ ಅಗೇನ್ if we simplify we get the same sigma by epsilon naught. So ಇದನ್ನ ಡೈರೆಕ್ಟ್ಲಿ conductors, so properties of conductors in an electric field ಅಂತ ಟಾಪಿಕ್ ಅಲ್ಲಿ ಕೂಡ ನಾವು ಡಿಸ್ಕಸ್ ಮಾಡಿದ್ವಿ. ಸೊ ಫ್ರಮ್ ದೇರ್ ವಿ ಕ್ಯಾನ್ ಡೈರೆಕ್ಟ್ಲಿ ರೈಟ್ E is equals to sigma by epsilon naught. ಸೊ ಈ ರಿಲೇಶನ್ ನ ಡೈರೆಕ್ಟ್ ಆಗಿ ಬರ್ಕೊಳ್ಳಿ. ಸೊ ಸಿಗ್ಮಾಗೆ we have the relation Q by A, that is surface charge density, so charge per unit area, right? So substitute ಮಾಡಿ simplify ಮಾಡಿದ್ರೆ we get, so ಮತ್ತೆ ಈ ರಿಲೇಶನ್ ಕೂಡ ನೆನಪಿರಬೇಕು. again from the definition, it is the ratio of the charge per unit volt, so that is for the capacitance, right? So substitute ಮಾಡಿ simplify ಮಾಡಿದ್ರೆ we get the relation C is equals to epsilon naught A by D, right? So this is the formula or expression for the parallel plate capacitor, right? So next, derive the expression for energy stored in a charged capacitor. So that we will discuss in our next class, right? Thank you.